The horseshoe crab is one of the most resilient and enigmatic creatures in the animal kingdom, with a history that spans over 450 million years and a role that's nothing short of crucial in the delicate balance of our ocean's ecosystems. Its ancient eyes, which can detect the slightest movements and changes in light, have witnessed the rise and fall of civilizations, and its humble body has been a cornerstone for the survival of countless species, from migratory birds to marine predators. As we embark on this journey to unravel the secrets of the horseshoe crab, get ready to be swept into a world where primordial landscapes meet cutting-edge science, and the boundaries between past and present blur beneath the waves. Belonging to the family Limululidae, the horseshoe crab is a member of a small group of marine animals known as chelicerates, which also includes spiders, scorpions, and ticks. However, despite these terrestrial relatives, the horseshoe crab has evolved to become one of the most iconic and enduring symbols of our ocean's ecosystems. One of the key mechanisms behind its success is its unique body plan, which features a distinctive horseshoe-shaped shell, or carapace, that protects its vital organs. This shell is made up of a hard calcium carbonate-based material that provides excellent protection against predators, while also allowing for flexibility and movement. The horseshoe crab's shell is also covered in a series of tiny, hair-like structures called setae, which help to detect vibrations and movements in the water. My expeditions in the field have taken me to the coastal waters of Asia and North America, where I've had the privilege of observing horseshoe crabs in their natural habitat. These areas are typically characterized by shallow, sandy, or muddy bottoms where the crabs can feed on small invertebrates, algae, and detritus. As I've watched them move slowly across the seafloor, their many eyes scanning the surroundings for potential threats or food sources, I've been struck by the sheer resilience of these animals. The evolutionary history of the horseshoe crab is a long and fascinating one, with fossil records showing that they have remained largely unchanged for over 450 million years. In fact, they are often referred to as living fossils due to their ability to thrive in a wide range of environments and their resistance to extinction. One of the earliest scientific descriptions of the horseshoe crab was made by the Swedish botanist and zoologist Carolus Linnaeus, who included them in his groundbreaking work, Systema Naturae, in 1758. For example, their eggs are an important food source for many migratory birds, such as the red knot, which relies on them to fuel its long journeys. The crabs themselves also serve as a prey species for a variety of marine predators, including sharks, rays, and turtles. In addition, they have a symbiotic relationship with certain species of plankton and algae, which live among their setae and provide them with additional nutrients. Despite their importance in the ocean's ecosystems, horseshoe crabs are facing a number of significant threats, including habitat loss, overfishing, and climate change. Their populations are often fragmented and isolated, making them more vulnerable to extinction. In some areas, they are also being harvested for their eggs, which are used in the production of fertilizers and animal feed. As a result, conservation efforts are underway to protect these incredible animals and their habitats, including the establishment of protected areas and the development of sustainable fishing practices. During my expeditions in the field, I've had the privilege of witnessing these incredible events firsthand. In the shallow waters of Delaware Bay, for example, I've watched as thousands of horseshoe crabs gather on the beaches during the full moon and new moon phases, their ancient bodies undulating in unison as they prepare to mate. The males, slightly smaller than the females, will often attach themselves to the female's shell using a specialized claw, forming a tight bond that allows them to ride the currents together. As the females begin to dig nests in the sand, the males will fertilize the eggs, which are then deposited into the nest. This intricate dance is not only a testament to the horseshoe crab's remarkable adaptability, but also a crucial component of its life cycle. One of the key researchers who has contributed significantly to our understanding of horseshoe crab behavior is Dr. Ruth Carmichael, a marine biologist who has spent years studying their mating habits and habitat preferences. Her work has shown that the crab spawning sites are often closely tied to specific sediment types and coastal geomorphologies, highlighting the importance of preserving these unique habitats. In addition to their role in the food chain, horseshoe crabs have also been found to have a symbiotic relationship with certain species of plankton and algae, which live among their setae and provide them with additional nutrients. This complex web of relationships is a testament to the incredible diversity and resilience of marine ecosystems. Despite their importance, horseshoe crabs are facing significant threats, including habitat loss, overfishing, and climate change. Rising sea levels and increased storm frequency are altering the coastal habitats where they spawn, while warming waters are affecting the distribution and abundance of their prey species. One of the most pressing mysteries surrounding horseshoe crabs is the impact of climate change on their populations. researchers are working to understand how changes in ocean temperature and chemistry will affect their growth rates, reproduction, and overall survival. For example, studies have shown that increased CO2 levels can affect the crab's ability to build their shells, while warmer waters can alter the timing of their spawning events. The larvae, known as trilobite larvae, emerge from the eggs after about 2 weeks and drift in the water column, feeding on plankton and small organisms. This stage is crucial for their survival, as they are vulnerable to predators and must navigate the challenges of the ocean environment. One of the most intriguing aspects of horseshoe crab larval development is their unique molting process. As they grow, they shed their shells several times, a process that allows them to increase in size and develop their characteristic body shape. This molting process is not only essential for their growth, but also provides scientists with valuable insights into their developmental biology. Researchers like Dr. Cheryl Zimmer, a marine biologist at the University of Delaware, have dedicated their careers to studying horseshoe crab larval development and its implications for conservation efforts. Her work has shown that the larvae are highly sensitive to changes in water temperature and quality, which can impact their growth rates and survival. In addition to their larval development, horseshoe crabs also exhibit complex behaviors as adults, particularly during their migratory journeys. Every year, thousands of horseshoe crabs migrate to their spawning grounds, often traveling long distances to reach their preferred habitats. These migrations are not only impressive, but also play a critical role in maintaining the health of coastal ecosystems. For example, in Delaware Bay, horseshoe crabs migrate to the beaches during the full moon and new moon phases, where they mate and lay eggs. This synchronized spawning event is not only a spectacle to behold, but also provides a vital source of food for migratory birds, such as the red knot, which rely on the crab eggs to fuel their journeys. The study of horseshoe crab migrations has also shed light on their remarkable navigational abilities. Researchers have found that these crabs use a combination of celestial cues, magnetic fields, and even the Earth's gravitational field to guide their migrations. This complex navigation system allows them to return to their spawning grounds with remarkable accuracy, often traveling hundreds of miles to reach their preferred habitats. Their remarkable life cycle, intricate behaviors, and resilience in the face of adversity teach us valuable lessons about the interconnectedness of life and the importance of preserving the natural world. The horseshoe crab story is a testament to the awe-inspiring complexity and beauty of nature, reminding us that even the smallest creatures can have a profound impact on the world around them. That's all for today's Nature with Aristotle. Remember to like, share, and subscribe, and until next time, may your curiosity about the natural world continue to flourish.